We are a Swiss startup that is tackling the multi-billion-dollar challenge of composite waste.
So this is the beast. This is our machine. But basically, it was not possible to recycle composites, and especially in the boating industry. We decided that low temperature pyrolysis is really the key solution. The main advantage is that you go back to products that you'll be able to use to make new composites. It's possible to treat pretty much everything. After a few hours, what comes out of it is basically carbon fibers that can reuse. You can see that they're free from any resin. When we realized that the industry is not willing to take a step, we take it ourselves.
Bringing circularity into this market, which traditionally has been very conservative.
So, as you see, we are in front of Composite Recycling. They are expecting us today.
Welcome to Composite Recycling.
Thank you. Let's go in.
Yes.
So, Smaranda, thank you very much to welcome me today here at Composite Recycling.
Glad you could come.
Can you say a few words about the company and your role in the company?
Yes, sure. So I'm Smaranda Jaun. I'm the CEO of Composite Recycling. And we are a Swiss startup that is tackling the multi-billion-dollar challenge of composite waste, a challenge that is actually still growing. We are recycling composite waste with a technology that is called thermolysis, where we heat up the waste in an oxygen-free environment, and that makes the resin separate from the fibers. And therefore, we have two outputs. We have either the clean glass or carbon fibers, and in parallel, we have the thermolysis oil. And we will invite you to see our facilities, which are just next door. So you can see our pilot unit that today is operational and that is already bringing revenues for our clients.
Amazing. I mean, thank you for the opportunity. And let's see what happens at the recycling facility. Hi, Pascal.
Hi, Yannick.
Good to see you. So Smaranda told us that we have the chance to look at the container solution. At least that's how I know your technology. So maybe you can introduce along the way what you are doing here. We will speak about legacy and the future of composite recycling.
Sounds good. Sounds good. Let's come inside.
Thanks.
So this is the beast. This is our machine where we're recycling composites. It consists in an oven, and you see the oven here. So we place the composites in a rack system, which you can see here. Slide the right in, and then we heat up without oxygen. That's the principle, actually. It's very basic in a sense, but it works well. Was tested in the lab at first, and just upscale the solution, you see.
And Pascal, tell us more about why you selected this solution, which is thermal, I assume pyrolysis, something similar. Why did you select it, and can you basically recycle any kind of composites?
Nice.
I'm speaking end of life, post-production, glass fiber, carbon fiber.
It's a very interesting question. At first, we're completely agnostic. We had in mind this issue that basically it was not possible to recycle composites, and especially in the boating industry. So we decided to investigate, and we envisaged several solutions, Thermolysis and mechanical recycling and so forth. And after investigating a bit, say 6 months, we decided that low temperature pyrolysis is really the key solution. So it's very versatile. The main advantage is that you go back to products that you'll be able to use to make new composites. That's really the key. And to go back to your question, whether we can treat anything, yes, it's possible to treat pretty much everything, especially with our system. which is large enough to accommodate entire pieces. So of course, we're not talking about very large scale composites like wind blades and so forth, where you need to cut the sample into smaller pieces, right? But decent sized composites, that's indeed possible with our system. The other point is related to the material. Material system wise, yes, it's possible to treat whether glass fibers or carbon fibers based composites. The solution can basically used in the same way, in the same conditions, pretty much. What changes a bit is the matrix. So you want to choose the right temperature to reach the thermolysis conditions for each matrix that is associated to the fibers. So right now we're focusing on 3 systems: epoxy, polyester, and helium, this thermoplastic developed by Arkema, right? Yeah, and this is how actually you can treat probably 95% what's out there on the market.
How long does it take to get the material out, to get the fibers, and you will also tell us more about to get the resin out of the reactor?
So first of all, actually we go back maybe to the first step, which is lab testing. That's very important to understand the output as a function of the input. So that's the first step. When we treat a new material, we go back to the lab, the kilo scale, and we analyze what comes out of it. The thermolysis oil and the fibers. Maybe we can talk about the output, indeed, actually. So when you treat polyester, you have a lot of styrene, benzene, xylene, toluene, so molecules that are commodities in the market, which is very interesting. For epoxies, you have a lot of phenols and things that in the end, you'll be able to extract through distillation. That's an additional step that we are integrating as well within the company. And then as for the fibers, we analyze that with microscopy to check the contamination level for potential reuse, right? Now, for the duration of the cycle, it's a good question. So it depends very much on the thickness of the composite. Whether it's polyester or epoxy doesn't change much, but you are in the order of hours for the entire cycle. Ideally, we wouldn't be aiming for 6 or 7 hours for the entire cycle, right? And so that you can accommodate a few cycles per day. But for very thick composites, I think that the thickest we've ever treated was 40 millimeters. There, you're in the range of 10 to 12 hours. Yeah. So, but that's pretty exceptional, right? So this is the order of magnitude.
Now, this is a pilot plant, I understand. What is the capacity, let's say, the yearly capacity in average? And where do you want to go in the future with the next generation after the pilot plant, the industrial plants?
You can consider that this unit can treat, say, 200 to 300 tons per year, right? And the next step, which is a big step, it's to upscale it to 4,000 tons per year. Okay. We were advised on the X, right, that we could reach, and it seems like it's a decent step to take. The unit will be installed in France. We have a partnership with Veolia, yes. And Veolia will take the waste and will be treating the waste. So it was very important to partner with such a large waste management company to ensure that indeed actually we get the right volumes.
Maybe you can show us some products which are going in, and then we will see also how it comes out.
Yes, absolutely. Let's do that. So typical samples are made of carbon fibers, and that's the kind of product that we treat. And the good thing with our machine is that we don't need to cut this material. So you can accommodate it as it is, you see. That's a major advantage. And after a few hours, what comes out of it is basically carbon fibers that you can reuse. I can show you the typical carbon fibers that we have. So this is the kind of fibers that come out. Yes, yeah, sure. So you can see that they're free from any resin, right? And this can be integrated into new products. So we have the option indeed actually to treat the carbon fibers or the glass fibers, because as you can see, the sizing is gone. So that's a very important step. So we're working with EPFL, with group of Véronique Michaud, to put back the sizing. So this is the kind of fibers actually that we get from the sample that I showed you, and you can see that they're basically free from any plastic, right? Yes. And that's the typical sample that we get.
That's many partners. We heard Veolia, Arkema, EPFL. So where do you really start, or what is basically the core asset for composite recycling? Because you have this machine, you are obviously adding some sizing. You spoke also about the resin side, so distillation is an option. Are you integrating this also?
Yes. We go for the simplest, but when we realize that the industry is not willing to take a step, we take it ourselves, you see. For distillation, we realized that the thermolysis oil was not marketable as such, and that we could increase the value by extracting the molecules, so that you switch from the sale of thermolysis oil, which is not a commodity, because it depends very much on the kind of plastic it comes from, you see, to sales of commodity products like styrene, benzene, and so forth, you see. And it's more or less the same thing for the fibers. We do have customers that are now asking for sized fibers. This is the simplest scheme. And it simplifies the operations, definitely. But then, in this spirit of adding value to our product, and since there's a market for that, and it broadens our perspectives, we decided to go for indeed this additional step of putting the sizing back on the fibers. Yeah.
And what are, I guess there are many challenges along the value chain, because it's being established. We have a lot of bricks, but maybe bringing the bricks together is not that easy. As you say, sometimes you need to make it happen yourself, while maybe it would be better to scale outside. But for now, it's about making it happen. So what is the main hurdle? I mean, for you, eventually as a company, but also for the industry, the recycling industry, let's call it like that.
There are several things I can think of, but one is consistency of the input, knowing the waste that you treat. And this is why for now, we're focusing on production scraps, with the aim pretty soon actually to address end of life as well. That's a major challenge, knowing what is in your composite. And so second challenge is maybe getting the authorizations to operate. That's a major challenge indeed, actually. And we're going through this in France in particular. So we identified a region, the northwest of France, which is very active for the composite industry. And so now we're in the process of preparing and finding the application. So that's what is good, is that when you did it for one country, especially in Europe, you can replicate pretty much, because there's homogeneity in the legislation across Europe. Not exactly the same, but I would say it's pretty homogeneous. So that's the second challenge. And the third challenge is really to match the output with the input, you see. So understanding what customers are willing to purchase the output, as a function of the input, and you need to adapt actually to go back and forth in the supply chain. It's very important, and you cannot really know for sure if you can sell a product before testing the whole chain. You see, and having results like in terms of microscopy, characterization of the oil, and so forth. So this is a challenge in a sense, and that's what we've been working on for the past few years.
So you mentioned the last point on the matchmaking being a critical asset. I would say it's knowledge, it's know-how of the company, but would it be at scale, especially if it's about end of life and traceability involving lots of companies over many years? Would that be a brokerage function in the market to have kind of an open database eventually allowing this very transparent matchmaking? Would that help?
Yes, that would definitely help. We have a master student working on traceability, and associated to that, so to this matchmaking table, right? You need to have a traceability mechanism in place, right? So you need to be able to understand where the waste is coming from, especially because it comes from multiple streams. You have the fiber side, you have the coatings, matrix, and so forth. So it becomes quite complex, but definitely this will help for sure.
And you mentioned the topic of permits. So obviously, being a challenge, because it can be solved, you have partners to do so in France. And in general, I know your company because of the container size. This is a pilot plant. The 4,000 will certainly not fit in a container.
Certainly not.
And then where do you put this facility? Is it on a private land which you operate? Is it at a waste management company? Who is operating it?
We are operating, in any case, the plant, you see. But we haven't decided yet, for sure, whether we will own the land or we would install the facility on a site of a waste management company. This hasn't been decided, and it's being decided actually right now. This depends mainly on the authorizations the waste management company already has, you see, and whether we could extend those authorizations to our activity. Right. It is for sure way harder to start from a land that is not equipped. I can think of many things, but the land has to be prepared and already compliant. Thinking of the thermolysis oil, so the land has to be equipped in case we spill some oil. You see, this can happen, unfortunately. And to minimize the impact on the environment. So it would be much harder to start from a blank page. And when we put in service the 4,000 tons per year unit in a couple of years from now, 18 months to 24 months from now. So there's still a bit of time, but we need to prepare for that already now.
Thank you very much, Pascal, for this tour in your facility.
Thank you, Yannick.
And we will go back to Smaranda to understand also how you need financial support to make it happen.
Perfect.
Thank you.
Thank you.
So here we are back with you, Smaranda. You welcomed us a few hours ago. Then we had the chance to see the facility with a production machine with Pascal. So we got a good impression of the tech, the entire value chain, at least what you have under control, from what is coming in to what is coming out, all the partners you're working with at industrial level. Why composite recycling, or why the composites industry?
So, well, I think Composite Recycling is a very interesting company in the good industry. There is a lot of momentum in the industry today, at least for what we are doing, like bringing circularity into this market, which traditionally has been very conservative and where materials used in all these big industries went directly to landfilling. So I think it's a very important contribution that we're making today in doing this recycling and actually also integrating the high quality fibers into new productions. So there is the direct application of our work.
Mm-hmm. So you say you're interested into the contributing to the positive impact in this industry. That makes sense. I mean, we are speaking a lot about sustainability and this positive impact. But what about the business? Because it will not happen if there is no business case. So how do you see that with your background on what does it take for a company to be successful beyond the technology only?
Well, obviously, it's a lot about the team. Today, we're a small team of about 6 full-time employees. So it is really small for everything we have managed to achieve. And the growth is not obvious. I mean, you always have to put a lot of effort into making it take off. But the way we want to grow is through partnerships with big industrial players. And as you have seen, we have a very nice alliance in the boating industry. And such kind of partnerships where you go from industrial players, you pass through waste management, and you also work on the fibers and the oil side. These kind of partnerships or alliances can be also created in other industries, like the automotive industry, like aeronautics, and also tackling the big wind turbine blade challenge.
Obviously, a company wants to generate revenue and to be break even at one point. So what does it take to become break even in this industry, or at least on your roadmap? How does it look like?
Well, so for our industry, for recycling, it's all about volumes. We need to go up in volumes, and today we can not be break even with our pilot unit. But as we scale up in capacity, in treatment capacity, and as we sign long-term contracts with our clients, maintaining a good pricing, we can actually reach very interesting margins, and eventually that is going to lead us to break even. So we expect, if the first large-scale machine will be operational already in 2027, we expect to be break even about 3 years from now.
Yes, around 29, 30.
Yeah, maybe even the end of 28, 29, yeah.
I mean, I think, thank you a lot for all the insights. Eventually you have a few words to close. So
reach out to us, and obviously we're supporting any discussions that are about circularity, about bringing this traditional industry one step forward.
And thank you so much for having us here in your facility. All the best, and see you soon in Paris.
Yes, thank you so much, Yannick.
Thank you.